Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag again. And today I'm going to take one more important topic of chart work, which is called your horizontal sextant angle, or simply called as horizontal angle. So let us look into this new concept today. So horizontal sextant angle is also called as HSA, or you can even call it as HA also. To start this concept, what I'm going to do is let me take one example with values, so I can solve it for you on the PPT as well as later on the piece of the chart in the PPT also. Let us start off this. This is a question. This is an MMD question. He's telling me a vessel is anchored, and he has given me three lighthouses, and all of them have got a compass bearing reading given to me. My job is to find the position of the vessel and as well as compass error. And it says that the error was same for all the three observations. So it has got a meaning. Let us see what it is. Okay, I'm going to quickly look into what is given to us. You can see that it is anchored, so obviously it is going to be at a constant place. And it also mentions that compass error is same, so which tells me a clue that it was at a constant heading. So that was the idea for giving me that clue in the question. Now, from the next slide onwards, I'm going to use what all clues were given in the question to justify what method I'm going to do. If you ask me, majority or the biggest challenge for any candidate is not solving the problem, but it is more of analysis and then coming to a conclusion that what method or what concept should I start with. So I'll try to give it on a step-by-step sequence. So try to use this for your questions also. Now, before I start the actual question, I'm going to just give you a gist of this particular question. So I've taken the chart. I'm going to show you what light he's talking about and what data is given in the question first of all. Let us see what is given. Okay, he has given me three lighthouses. I've just marked a star near that lighthouse so that you can see it is abacus, sorry, abacus. And the second one is Weistad, the south light, which is the tip of the land. And the third one is here. So please be cautious. Right now in this question, there's a land on one side and there's water on the other side. So we know you can only anchor at this approximate spot. This is not the exact spot, approximately somewhere here. Not all questions are like this, so please be careful on this. But there is something very important. Please never plot any compass bearing, nor magnetic bearing, nor gyro bearings on the chart. You're supposed to plot only true. So this picture, before I start solving, is only for depiction, just to show you that how this question is posed and where you can find yourself. But I need to find the exact answer, so let us see how to do it. Now, he has given me three compass bearings. So basically from the vessel, somebody took the standard compass reading of Abacus, 298 compass. Weistad was 009 and this light was 078 compass. All of them are compass. So I cannot plot it directly on the chart. This is just depictive. And please remember, this is not a fix. This is not your position. This is just approximately where you could be. So just to show you an overview of this question, I made this slide. But let us start off how exactly would you go about in your real exam. So let us quickly look into this feature. In the last video, we had seen that if I'm given two or more position fixing tools at the same time, it is simultaneous. So you can see this question is also simultaneous. Now he has given me three compass bearings. Whenever he gives you compass bearings or magnetic bearings or gyro bearings, your first thought should go, can I convert them into true? So for a compass, if I want to convert into true, I need variation and deviation. So where can you get variation in your exam? It'll be there either specifically given to you in your question, or it could be on the top notes in your question paper. If both of them are not there, then I'll have to use my closest compass rose and find it for this particular year in which you are solving the problem. So if it is 2023, please convert that into 2023. Now, deviation, where can you get it? You will get it on the deviation card. But please remember the most important thing, deviation card is made for particular heading. They are for different headings. So for me, I need to be given a heading. Now, let us look at a scenario where let us say that the heading was provided in the question. So all I would have done was picked up the variation. I would have gone to the deviation card, converted it, plotted them as 3 true bearings, and I would have got a fix. That's it. The problem is over. So that is too simple. What happens if the question is not providing a heading? And you would have seen that this question is not providing a heading. So I cannot use the deviation table. As simple as that. Please don't use deviation table for bearings. You should use it only for a vessel's heading. Now, whenever this situation comes, I'm going to look at the HSA method or HA method. Now, if you look into bifurcation of horizontal angle method or HSA method, you could give it 5 different cases, but I'm going to deal with only one of the cases today in this module. So we'll see what is that case and we'll look into that. Now there's one more catch. Horizontal angle cannot be more than 180 degrees. There's a logic behind it because you are supposed to look at the shorter angle. So what happens if your value of horizontal angle is more than 180? Then all you do is please subtract from 360 and you'll get the shorter angle. I'll show you a sample, what if you do by mistake and how you can correct it. Look at this same question. I've just shown you the first 2 sets of lights, Abhikas and the Y stat. I'm looking at the shorter angle. This is the shorter angle. I should avoid using this larger angle. Please do not use it. Okay. Even if you use it, then you'll have to convert. Similarly, for the second set of the lighthouses, I'm looking at this angle shorter and not this. So please be careful about this one. Okay. Now, let us do our small analysis in this question. What all have we found out? I have realized that it is a simultaneous fix because all the 3 are at the same time. The vessel was anchored. I'm giving you a compass bearing. Obviously, I can consider all the 3 bearings were taken at very short intervals, so heading is constant. But no heading was given to me, so I have to go by HSA method. So this is the analysis for me. There is a quick word of caution, which I had earlier also told you. Not all questions come like this one, where one side of the chart is fully land and the other side is water. You will not get always. You might get 2 lights which are in 2 islands, and there's water all over the 2 islands. So a small confusion creeps in. So how do you sort out this confusion? Let us quickly look into that. I'm supposed to use a logical conclusion deciding compared to the 2 lighthouses given to me for a set of horizontal angles, which side I am in, whether I am this particular question, whether I am south of the 2 lighthouses or I am north of 2 lighthouses. It can be applied to all. So I'm going to show you how to use that. I'm going to use the compass rose as a reference mark to decide whether I am south of the 2 lighthouses or north. It could be west, east, whatever it is. I'm just comparing the 2 lighthouses. This particular question, you can see everything is south. Okay. So even though compass rose talks about true, but I can still use it. So how do I use it roughly to judge? I'll put myself always at the center of the compass rose, and then I'm going to put those lighthouses approximately. You can see I marked them 298. Even though it was compass reading, I marked it on the true reading. It's okay, just for analysis. And this was 009, and this is 078. Now, if you look at it, this is the angle I want. This is the angle I want in the second set of the lighthouses. But I need to decide, compared to the first two lighthouses, where am I? Obviously, if I take a bearing which is northwesterly and almost northerly, which is compass also, that means I'm south of this yellow color line. Similarly, here also, one bearing was almost northerly. The second one is almost easterly. So obviously, I'm kind of southwesterly of this second yellow color line. So this is the logical conclusion I'm going to use in the next slide. Please remember this picture. It's very easy. Always put it with the center of the compass rose. Let us go into this case one, which I call it theta is less than 90. I've just given you a small clue. It gives me only one position fixing tool, which is a position circle. So two sets of lights gives me one horizontal angle, and one horizontal angle gives me one PC as far as the angle is less than 90 degrees. So let us go into this particular question. I've just copied the bearings again, and let us look at the steps. So approximately, I call the first lighthouse as X, second as Y, which was your Abacus and Y stud. Please look at the horizontal angle. The shorter angle was 71 degrees. That is what we have calculated. So this is theta 71, obviously. Theta is less than 90 degrees. Now, what do you do if by mistake you do 298 minus 009? You will get an answer called 289, which is wrong because horizontal angle cannot be more than 180 degree. So all you do is 360 minus 289, you will get the same 71. So no big deal if you do a mistake, please correct it. Now, the next step for me after finding theta is finding something called alpha. Your alpha is nothing but 90 minus theta. I've got a value of 19 degrees, 19 degrees. Now, I'm going to use this alpha to solve a problem because this is a geometric theorem of circles. So I'm not going into the concept. I'm just looking at the procedure. Now join the two lighthouses. Doesn't matter if it is land or no land. Please join the two lighthouses. I call it X and Y. Now my job is to find logically whether I am south of this yellow color line or north of the yellow color line. And we just saw in the previous slide with your compass rose, I very well figured out that I am south of this line. So I call it towards the vessel is south of the line. Why I need it? Let us see. Now, even though I use the compass rose, which is based on true, I'm still, I was using this compass rose, but why I am so confident that I can still use the compass rose and get a correct value is because compass error may not be more than maybe 10, 20 degrees. So still your judgment of south and north of this line will still come correct. So please use it without any hesitation. Now I got theta less than 90. So what is this towards the vessel or away from the vessel, which is northerly side? What do I do? For everything which is theta less than 90, I'm going to do some steps which is towards my vessel. That means I'm going to look at this yellow color line and I'm going to see something towards the vessel. This is where I'm going to use alpha. I'm going to make two more lines with an angle alpha, and I call this yellow color line as a baseline. Okay, so I'm going to draw two more lines with an angle alpha with the baseline towards my vessel. So I'm going to do the same thing with Yankee also. So you can see, because theta was less than 90, I will always draw alpha towards my vessel from the baseline. So wherever this two baselines intersect, I call it center, Charlie. This C or Charlie is the center of the position circle which I'm going to draw. So how do I draw? I'm going to take radius from Charlie as Charlie X-ray or Charlie Yankee. Both have to be same. If they don't come same, then that means there is a small error in your diagram. So be careful in plotting small angles alpha. Sometimes angles are quite less than 10 degrees and all. You'll have to be careful. So take Charlie as the center with your compass. Take the radius as X-ray, Charlie X-ray or Charlie Yankee, and draw a circle. So this is the circle which I call position circle 1. So I've just given a time 8 o'clock. It could be any time. It's okay. Now, what do you mean by position circle? A circle where I can find my position. It could be anywhere. I've just given you 2 spots with orange color. I could be anywhere. That is immaterial. Now, similarly, exactly the same procedure I'll be doing with the next 2 lighthouses, which is your Weistad and the third one. I call it Yankee and Zulu. I would have done exactly the same thing, which I'm going to show you on the chart. So I'm going to skip a couple of steps here. I'll be showing you the rest of them on the chart. So I would have got this Zulu. I would have drawn the baseline, and I would have drawn there also alpha. Then with the center, I would have drawn one more position circle. So I've got 2 position circles. Both of them are the same time. So obviously it is a simultaneous fix. So wherever they intersect, I can have a fix. But you can see these circles are intersecting at one more point. That one more point is that Weistad lighthouses. Usually the middle light, that is where your second intersection will come. So obviously you're not at the Weistad lighthouses. So that is ambiguity, which I can discard. Please discard that ambiguity. So I'm going to leave that. Now, let us go with this particular question in full. I'm going to show you in the chart. So what I would have done, I would have sat down on the compass rose. I would have put all the 3 lighthouses. I would have measured the angle θ1 and θ2. So θ1 is 71, θ2 is 69. And with the baseline, I figured out that with both the baselines, I am south of the lighthouses. So I'm going to proceed with the chart now. Let us exactly do what is required. So I'll be joining the baseline for first and second lighthouses. I know θ1 is 71, alpha 1 is 19. Since theta is less than 90, I'm going to come towards my vessel. So this is your first line from alpha 1, second line from alpha 1. I got a Charlie and I'm drawing a position circle. You can see the position circle should intersect both the lighthouses. So this is your PC1. I will do the same thing for the second set of lighthouses. Again, θ1 is less than 90. So I have alpha 2 here. Sorry, θ2 is less than 90, alpha 2. Again, 2 alpha 2s from the baseline towards my vessel. And one more position circle. You can see there are 2 intersections. Obviously, the top intersection I'm going to discard because that is of the lighthouse. So this is your fix. Please find the position of the fix in lat long and you can give the answer. I've not done the position, but this is good enough for you to understand. Now, the second condition or the question of this particular problem was, how do you find the error? So how do you find the error? Let us see what you do. I've got this plot on the chart. I've got a fix also. So if you agree that fix is my real position, I can always join my fix to the lighthouse, and on the chart it will give me the true bearings. So this is the true bearing of X, true bearing of Y, true bearing of Z. So I got 3 true bearings. Now I'm going to compare the compass bearing given to me in the question for each one of them. I'll show you the values with sample values. And that is the error. So please see here, the same thing I've written A, B, C. So 298, let us say the true bearing was 300, error is 2 degree east. Same thing for the second one and third one. You can see the 3 errors are slightly different. It is possible. It depends on a lot of errors, the chart error, your plotting error, human error. It's okay. Uh, so what do? You find the average of the three errors and give the answer. So for me, 2 plus 3 plus 2 divided by 3, I'm getting 2.3 degree east. So please write this as an answer. Don't write the majority, please write the average. It's okay. Now, I've gone one step further. What happens if somebody asks you to calculate the deviation at that moment also? It's pretty simple. Let us quickly look at the next step. Now, when you do the normal conversions between your variation, deviation, error, you will always realize that error is basically the algebraic sum of V and D. So I can use the same principle. And let us assume in this question, V was given to me as a fixed value, or I found out from the compass rose. So constant variation was 3 degrees. Your average error was 2.3 east. So when I convert, I can get a value of deviation as 5.3, 5.3 east. So they can always ask you the deviation also. Please be ready for that. And you can complete this problem. This problem could extend further, but my idea was to just show you what is your horizontal angles or horizontal sextant angles. Uh, this gives you the basic idea, but I have chosen to do only one case. I will see in future, I might go into the other cases also. They are very similar with slight difference how you approach different cases. Well, anyway, that's it about horizontal sextant angles. Please keep watching Jalprayag, and I'll catch you soon with my new video. Till then, Vanakkam, Namaste, Namaskar.